Hello everyone and welcome to this additional tutorial. In this tutorial, we will be performing activities on a network, which include demonstrating how to use virtual machines to simulate network environments, performing connectivity and protocol tests, analyzing network traffic with a protocol analyzer tool called Wireshark. We will begin by creating our resources in Microsoft Azure, which is a cloud platform that lets you build, run, and manage applications and services through Microsoft data centers. If you want an in-depth tutorial on how to get started with Microsoft Azure and learn its features, I will link the video for that tutorial below. To get started, we will be creating the following resources in the Microsoft Azure resource group, and then we'll continue into making a Windows virtual machine, then a Linux virtual machine. We'll also create a new virtual network. Then we will proceed into logging into the virtual machine. And then once we are inside the Windows virtual machine, we'll install the protocol analyzer Wireshark, where we will observe all network activities. We will then test connectivity and connection to virtual machines and devices with ping. We'll also configure a firewall on our new virtual network and network security groups. Then inside Wireshark, we'll observe various protocols such as Secure Shell Protocol, DHCP, which is Dynamic Host Configuration Protocol, DNS, Domain Name System Traffic Protocol, RDP, Remote Desktop Protocol, and ICMP, Internet Control Message Protocol. Then at the end, we will log out and clean up all our resources. That way, we don't have a continuous running of charges up in Microsoft Azure. So let's get started. Continue going onto the Microsoft Azure platform, and we'll start right on the home page. The first thing that we'll do in Microsoft Azure is create a resource group. So navigate to resource groups, and then we want to go on create. Once we are in the create resource group portion, then we'll select the subscription that we're part of, and we'll name our resource group. I will name this resource group Network Test, and then we will click on Review and Create, and click on Create again. And once successful, a notification will show up that the resource group has been created. Once you refresh the page and go back to home, you will see the network test resource group created. The next thing we want to do is create a virtual network. That will be needed in order for us to put the virtual machines that we will create after to be inside the same virtual network. Click on Virtual Networks. Create. Make sure you select the resource group that we just created, Network Test. Then name your virtual network. I will name it Network Test as well. Review and create. And click Create again. Now deployment is in progress. We'll just wait for this to finish. Click back on Home, and you'll see that the Network Test virtual network has been created, and also a notification in the top right corner. Next thing we'll do is create our first virtual machine, which will be the Windows virtual machine. Click on Virtual Machines. And from then, click on Create. We want this to go into the resource group that we created earlier, Network Test. Then we'll name this Windows VM. Leave the region as East US 2. This option can stay, this zone can stay. Here we'll select Windows 10, x64 Gen 2. Standard D2 V3 2 vCPUs with 8 gigs is good. Here we'll select a username, network test. I'll keep it simple. Password at 123, password at 123. A good note here when you're creating passwords and usernames is to keep a notepad on the side and just save that information. That way it's easily accessible. So here I have the Windows VM, I have the network test and the password just saved in my notes. That way when I go to log in, I can just have that stuff handy. Go back to our Microsoft Azure. Continue, make sure you check this box to confirm the licensing. Go next to disks. Again, next to networking. And here in the virtual network, we will see the option for the network test virtual network that we created. Click on that. This will also have a default subnet, which we can just select the default and leave everything else the way it is. Next, you can just click on review and create. Click on create again. And now our virtual machine for Windows is creating. Click back on home and let that finish. Okay, so now we see that the deployment has been successful in creating our virtual machine. We can refresh the page. If it's not showing up once you refresh the page, don't worry about it. Just go to virtual machines and check in there if it's showing up. If it's here, here it is, Windows VM, then you're good to go and it's running. So we're all set. It will show up on the home page eventually, but we can continue with the next step. So the next step is we're going to create another virtual machine, which will be a Linux virtual machine, and we'll put both virtual machines on the same network and we'll check to make sure they are on the same virtual network. So again, select the resource group that we created. Network test is the name of mine. Linux VM, we'll name this one. Here we'll select the Ubuntu server 24.04 LTS Gen 2. Same 2 vCPUs with 8 gigs. Make sure you select password here, and again, create a username that you can remember. I'm going to do a network test, password at 123, password at 123, and go next to disks, go next to networking, and here networking is where we're going to put it in the same virtual network as our other virtual machine is. So select network test. The subnet, we want to do the same default as we did in the other one, and then we'll continue to click on review and create. Okay, now click on create again. And let this finish creating. Deployment in progress, as you can see. Navigate back to home. See our Linux VM has showed up here. And double check, go to virtual machines. See, this is still deploying, so it's not ready yet. Still creating status. This is running. So give it a minute to finish. Deployment successful. So now we can refresh the page. And you can see both of our virtual machines are running and they're good. Let's just double check to make sure they're in the same virtual network. So click on the Windows VM. In Overview, you will see that the virtual network is network test. Click on Linux VM, and in Overview as well, you can see that the virtual network is also network test with the default subnet for both. So now we can go back to home, and now on our home page, we see that all our resources have been created. We have our resource group network test that we created first. We have the virtual network, which we created second, and then we created two virtual machines, a Windows and Linux, that are both on the same virtual network called network test. The next step in this tutorial will be for us to log into our Windows virtual machine. But before we do that, we have to just gather some information first. So what you want to do is click on the Windows VM, and then in the overview on the main page of it, you want to make sure that you copy and paste this public IP address somewhere into your notes. So I'm going to take this and copy it and open my notes, and I'm going to just paste this down here because I will need it to log into the Windows virtual machine. I'm on the Mac, so in order to log into virtual machines, you'll need this application called Windows App. So I already have it downloaded, but I'll run you through how to get it. So go to the App Store. In the App Store, you will type in Windows App. And it will look basically like this. I'm going to just go ahead and open it since I already have it on my computer. So once you're in the Windows app, you will see this screen right here that shows no devices. So you want to click on the plus sign here and then click on Add PC. For the PC name, it says hostname or IP address. So basically, you want to copy and paste. So you want to copy and paste the IP address into this box right here that says PC name. You can name this Windows VM and then click on Add. Then double click on this Windows VM box. This will ask to enter your credentials, the ones that we created in Microsoft Azure when we created the Windows virtual machine. You'll have it in your notes if you saved it. So go ahead and enter your username and the password. And this will start the process of logging us into the virtual machine. So click on continue, click on continue again. Wait for the load screen to go inside the virtual machine. Just say no to all these options and then click accept. And now we are inside the virtual machine. Just say no to that, exit that. Now inside the virtual machine, the first thing that we're going to do is install a protocol analyzer called Wireshark. Wireshark is a free open source network protocol analyzer used to capture and inspect data packets in real time for troubleshooting and security analysis. So go to the browser in your Windows virtual machine, Microsoft Edge. Just confirm. Okay. Exit. Go to the Wireshark website. Just type in Wireshark in the search. Now we want to do the Windows x64 installer. Click on that. Let it download. Once it downloads, open it. You might want to minimize that. It'll pop up in a second. If it doesn't, go to the folder, Find it there and run it. Now go to next, noted, next, next. Sure, we'll get a desktop icon. Next, next, next. You don't need to check this one. And let it install. I agree. You don't have to check any of these boxes. Just check install. Okay, installation complete. Click next, click finish. Okay, it's completed. Hit next and click finish. Exit the folder. Okay, so you want to open Wireshark. You can, if you don't have the desktop icon, you can type it in the search box and open it there. Now I'll just full screen it. And sometimes you'll have two options for Ethernet, and so you want to just observe which one. I always go for the one that's without the number. So the way you want to start a new packet capture is you take, click on the Ethernet, make sure it's blue selected, and then on the shark fin. And now we see all this data happening. So basically with the packet capture, we're seeing all the traffic that's happening on the back end of the computer. An IP packet is basically a small chunk of data sent over the internet that contains both the information being transferred and the necessary details like addresses for getting it to the right destination. The Wireshark software will capture the analysis from performing other various network tests. So we'll do some tests like that right now. The first test that we're going to be doing is testing connection to virtual machines and devices using ping. Ping is a network tool that sends a handshake signal to another device to see if it's online and measure how fast it responds. So for now, we can stop this packet capture. And what we want to do is we want to navigate back to the Microsoft Azure portal and copy some information in order to initiate the ping. So I'm on Mac, so you can either, if you go all the way down up, you can minimize this tab and your Mac will be shown there, or you can swipe the three fingers to the right and basically you can go back in between the Windows virtual machine and the Mac computer. So we want to go back to the Microsoft Azure portal and we want to click on the Linux virtual machine, and what we need is the private IP address. It's 10.0.0.5. So that's what we will need in order to ping and get a reply from the computer. And we'll observe all that traffic in Wireshark. So you can leave this open, swipe back. The first thing you want to do is new packet capture. In the search box, we want to type in ICMP, which is Internet Control Message Protocol, which is the specialized language that network devices use to send status updates, report errors, and check if a destination is reachable. So this will show the ping we are actually attempting. So what you want to do is type in a search box and search for PowerShell, Windows PowerShell. And now we will get this box where we can type in commands. So we want to type in ping and the IP address, the private IP address for the Linux virtual machine. And now we want to hit enter. And now we are seeing the reply and the request inside Wireshark. After we run the command in PowerShell, we see that it shows a successful connection where the Windows VM sends a request and the Linux VM sends a reply. So we can see the IP addresses. Here's the request by Windows virtual machine, which was, if we go back to Azure and go to Windows VM and look at its private IP address, it's 10.0.0.4. And we know that the Linux is 10.0.0.5 because we typed it right here. So we see the requests and the replies happening on this end. So the Windows VM sends a request and the Linux VM sends a reply, confirming both machines are talking to each other with zero data loss. Wireshark acts as a digital observer, capturing every ICMP packet to provide a visual transcript of the conversation between our Windows virtual machine and the Linux virtual machine. Okay, so the next thing that we will be doing is configuring a firewall in network security group, which is implementing an inbound security rule to successfully deny ICMP traffic on a virtual machine. So basically what we want to do is run a continuous ping and then block it from happening. So the way to do that is you want to first still filter for ICMP. And now in the Windows PowerShell, we want to do a continuous ping. And to do that, you type in ping, the private IP address of the Linux virtual machine, -T. And this will continually reply request. As you can see, it's happening in Wireshark and it's happening here. So now to make to configure the firewall, we want to go back to Azure. See, I swiped back again to the Mac. Now click on the Linux VM. On networking, click on network settings. In network settings, under network security group, click on Linux VM. And now here we want to go to inbound security rules under settings, add. Now you want to leave this as any. That's going to stay the same. This is going to stay the same. Change this to an asterisk. Now the protocol will be ICMP v4. Make sure your action is deny. Priority, you want to put it lower than this one. So put it at 290. And then name, you can just name block ping add. Now after this firewall was created and it's successfully been processed, as we see, the created security rule is all set. When you go back to Wireshark, you will see a block in the ping. So now you want to swipe back, wrong way. See how it requests timed out? So it's just going to keep timing out because we created that firewall. So if you want to remove this blockage, you basically have to go back to Microsoft Azure, to the Linux VM again. If you want, I can show you how to get back there. Go to Home, Linux VM, Network Settings, in Networking. Network Security Group. And now Inbound Security Rules. And now select the inbound security rule that we created, and you can click delete right here, or you can select it and click delete up here. I'm just going to do it up here. Hit yes. Now it's deleting the security rule. Now it's deleted. Now we swipe back to Wireshark, and the ping is continuing again. So that's how you create a firewall. And to stop the continuous ping, you just hit Control C, and that will stop the ping. In our next tutorial, we'll observe SSH traffic, which is Secure Shell. Secure Shell is a network protocol that allows you to securely access and control a device remotely. It operates by its default on TCP port 22. Its primary purpose is to create an encrypted tunnel so that sensitive data like username and password cannot be read by anyone intercepting the network traffic. In this demonstration, we'll use PowerShell to initiate an SSH connection while simultaneously capturing the packets with Wireshark. This will visually prove that all communication on port 22 is transformed into an unreadable encrypted text, confirming that the session is secure against eavesdropping and other interference. So we are here in Wireshark. What we want to do is swipe back to Azure to gather some information. So we'll go back to Azure, and then we want to click on the Linux VM. And when we are in the Linux VM, what we want to do is gather the private IP address. This is what we'll use in order to access the Linux virtual machine in PowerShell. So copy that 10.0.0.5, or just remember it. I'm going to copy it, swipe back, open PowerShell. Okay, just keep that open on the side. Minimize it if you like. Now, start a new packet capture, click on Ethernet and the blue fin. Now we want to filter for SSH only. Hit enter. Now in the Windows PowerShell, okay, here it is. What we want to do is type in SSH and then the username that we used for our Linux virtual machine, which will be network test. And then the IP address, the private IP address for the Linux VM, which was 10.0.0.5, and press enter to continue. Okay, so now we're seeing the SSH traffic is showing here in Wireshark. And now it's asking, are you sure you want to continue connecting? Type in yes. Now, what will happen is it will ask you for our password. But the thing to note here is when you're typing in keys, you will not see them, but it is encrypted. So they are going in there, but you just cannot see them. So make sure you type this password in correctly. My password is password at 123. Now hit enter once it's typed in correctly. And if here we are, we see that our connection has been made. So basically now we are seeing the Windows computer, the client, remotely managing a Linux computer, which is the server. This is a standard administrative connection used to run commands on a machine that isn't physically in front of you. So after we typed in the password, we're connecting, and now we are seeing the Windows computer, the client remotely managing a Linux computer, the server. And basically, this is a standard administrative connection used to run commands on a machine that isn't physically in front of you. And we use PowerShell to build a secure encrypted tunnel to the Linux machine at the address 10.0.0.5. And the remote control is Once we connected, the Linux machine sent its welcome screen to your Windows window, allowing you to type commands as if you were sitting right in front of it. So now we see that we are logged in as the network test.linux VM. We can type various commands to test the connection, such as ID. And it is a digital equivalent of showing your ID card to prove which user account you're using. So it shows the ID that you're using, which is network test. Then we can type in host name. When you saw Linux VM, the name, it confirmed our commands are being sent through the tunnel to the remote machine. So we understand that the host name, which was what we created when we created the Linux virtual machine, was Linux VM. And we also can type in something as uname -a, and it gives us detailed information of the engine under the hood, including the Linux version, the date it was built, and the type of hardware it's running on. So we can see all that kind of information in here. And if you type in exit, then it will exit the connection. But before we do that, we can just discuss what's happening in Wireshark. So in this Wireshark capture, we're watching a high security private conversation between the Windows virtual machine, which is the 10.0.0.4, and the Linux virtual machine, which is 10.0.0.5, which is happening over port 22. While Wireshark can see the envelope of the data moving back and forth, the SSH v2 protocol has scrambled the actual contents into those encrypted packets you see listed. This means that sensitive details like the password we typed in to log into, the specific Linux commands we're running, and even the text of the files you're editing are completely invisible to anyone sniffing the network. It's essentially a digital armored tunnel. Wireshark knows a conversation is happening, but hasn't a clue what is actually being said, which is exactly why SSH is the gold standard for secure remote management. And now to log out, we'll just type in exit right here into our PowerShell, and that will close our connection. Okay, so the next thing in our tutorial, what we'll do is observe DHCP, Dynamic Host Configuration Protocol traffic. DHCP is an automated service that assigns unique IP addresses and network settings to devices so they can connect to the internet instantly. In this tutorial, we will use Wireshark to observe this live negotiation as we trigger a fresh address request by performing a release and renew command in PowerShell. So what we want to do is start a new packet capture. And now we want to filter for DHCP, or we can also filter for its particular port, which is 67 or 68. So in this particular scenario, I'll just type in DHCP. Now, what we want to do is open a notepad in our Windows virtual machine, and we'll create a simple release and renew command file that we can put into PowerShell and have it run. So basically, you want to just type in ipconfig /release and ipconfig renew. So just to explain this a little bit more, the ipconfig release command tells your computer to drop its current IP address and disconnect from the network. The renew command forces the computer to start the network handshake process from scratch to get a fresh IP address from the DHCP server. The purpose is the best way to troubleshoot connection issues, or in our case, to generate fresh traffic so we can capture the exact moment our computer negotiates with the network in Wireshark. So now we want to click, we want to save this file. So we want to click on File, Save As. Now we want to save this into the C drive. So I'm going to type in C program data. And we're going to save it as name as DHCP.bat. .bat means it's a script file. Then we will hit save and exit this out. Now we want to open PowerShell. And we want to type in cd C program data. Now we're in the C drive. Now we want to type in ls for list. So now we're in our list. We see our file there. Now we want to type in backslash DHCP.bat and run the command. So again, in this final steps, I use the custom batch file to automate the ipconfig release and ipconfig renew commands, which forces the computer to give up its current IP address and request a fresh one from the network. And in the Wireshark capture, we can see the discover, offer, request, and acknowledge handshake play out in real time. And my machine discovers a server, receives an offer, requests that specific address, and finally receives an acknowledgement to confirm its new IP of the 10.0.0.4. This demonstration shows exactly how a device introduces itself to a network and secure the unique identity it needs to communicate with the world. So the next thing in our tutorial we'll do is observe domain name systems, DNS, which is basically like Internet's phone book, which automatically translates easy to remember web addresses like google.com into numeric IP addresses that computers used to find and talk to each other. So the first thing we'll do is do a new packet capture. Then we'll filter for DNS and enter. Now we want to open PowerShell. Once we open PowerShell, we want to type in NSLOOKUP and type in a website. I'm just using google.com as an example. So the NSLOOKUP command is a tool to test and troubleshoot the domain name systems. And after we type in NSLOOKUP, we type in the website or our choice, and this will, after we hit enter, it'll show us the IP addresses associated with this website. So after NSLOOKUP, type in no google.com. Actually, we want to put www. Hit enter. Now these are some of the IP addresses that are associated with google.com. And in PowerShell, after we run the command, the computer basically asked the DNS server for Google's phone number, IP addresses, and the server replies with a list of addresses where the website is located. Whereas in Wireshark, where the packets are being captured, the Windows VM 10.0.0.4 sent a request asking, where is Google? So we can, for example, take one of these addresses for a little test and we copy it, and then we open a browser, Microsoft Edge, and we paste it and then we hit enter, and there's Google. So basically, by entering the IP address directly into this browser, we're bypassing the DNS phone book. So we can take another one, for example, the 157.119, try that in a new browser, and we hit enter, we get Google again. So that verifies that these addresses, these IP addresses are just numerical values for what Google actually is, and what DNS does for us is translate those human numbers, those human names into those IP addresses. And even though sometimes the browser will flag the connection as not private, and when we can click continue, it allows the site to load because NSLOOKUP command successfully provided the service direct GPS coordinates IP address, proving that the DNS server is working correctly behind the scenes to translate the name into reachable destinations. So that is DNS in a nutshell, and here we see all the traffic in Wireshark associated with that. Okay, so the next thing we'll do in this tutorial is we'll observe RDP, Remote Desktop Protocol. RDP stands for Remote Desktop Protocol, which is a technology that allows us to connect to and control the distant computer over a network as if we were sitting directly in front of it. So the first thing we'll do is capture new packet, and then for the filter, we'll type in the actual port of RDP, which is TCP port 3389. So we want to type in TCP.port, two dashes, 3389. And now we hit enter. And now what it's showing is, so the filter TCP.port 3389 is used to isolate remote desktop traffic from all other network activity. The protocol, the TLS v1.2 we labeled that we see, confirms that the session is encrypted, ensuring that the live stream of data remains private and secure, constantly sending every screen change and mouse movement between devices. If we type anything in or move the mouse, it's going to show up here in this traffic movement. We're also seeing some of this red and black in here, and that's basically the network health. The highlighted black and red rows indicate TCP retransmissions, which occur when the network drops a piece of that live stream and must quickly resend it. So we see TCP retransmission in here. So they're going to be these black and red lines. And the packet details, which is the bottom panels right here, will display raw technical details of the connections, such as specific IP and MAC addresses involved in the stream, and we can find those things here. And also, the source data from which we're targeting, which is the Windows virtual machine, and also right here we see the transmission control protocol, and then we see the source port, which is the RDP 3389 port. So to wrap up, Remote Desktop Protocol shows up in Wireshark as a dense stream of encrypted TCP traffic, and it's on the port 3389 as we typed in above, and we filtered for it, and where every mouse movement and screen update and every keyboard click is updated and bundled into a secure packets, and they appear as unreadable data to ensure that a remote session remains private and protected from observers and other intrusions on the network. So the next thing that we'll do is observe ICMP traffic, which ICMP stands for Internet Control Message Protocol traffic. And its definition is a network diagnostic system used by utilities like Ping and Traceroute to verify reachability, map data paths, and report transmission errors to ensure efficient communication across the internet. So the first thing we want to do is start a new packet capture in Wireshark. And we want to filter for ICMP. ICMP does not use a port. So now we want to open PowerShell. And in PowerShell, we want to ping a website. So we'll ping google.com. And now we're seeing that the ping and the destination, which is essentially like the way of, talking to a computer if you're there across the network. So in the Wireshark capture, we can see the conversation happening between the virtual Windows virtual machine, and it sends the echo ping to the request, which was the Google website, to an outside address, and instantly the other device sends back the echo ping reply saying, yes, I am here. By looking at the PowerShell window and Wireshark together, we are proving that our network connection is healthy and that the data is successfully traveling to its destination and back without getting lost. So now we're still in the PowerShell. We want to type in this command ipconfig space all. And ipconfig -all is a little detailed version of a standard ipconfig tool that acts as a full identity report of the computer's network connection. While the basic command only shows IRP address, adding the all, which will reveal critical behind the scenes details such as the physical address, the unique hardware of ID of our network card, the DNS server and the phone books that look up websites, and whether your DHCP is enabled to automatically receive. So we see here if DHCP is enabled to automatically receive an IP address. And in this tutorial, this command is essential because it helps us to verify that the information we see in Wireshark, like the IP address of the Windows virtual machine, matches exactly where a computer is reporting internally. So to summarize the ICMP, the Internet Control Message Protocol, we used the ipconfig all to identify our local IP, and then we pinged Google, and we've successfully used Wireshark to capture the ICMP protocol in action, showing a clear request and reply handshake that proves our computer can find and talk to a web server across the internet. Okay, now just to finish our tutorial, we want to clean up some of these resources, because if we keep these virtual machines running or open or any kind of capabilities, then we'll be getting charged to Azure, and we don't want that. So let's just exit all these things out. And you don't have to uninstall Wireshark. Once we close and delete the virtual machine, everything will go with it. You can type in the command log off in here. You can simply go up top, exit this out, then delete the virtual machine. I like to just log off just so it signs out the way it's supposed to. Now once we're still here in the devices, we want to delete this. And that's where we accessed our Windows virtual machine. So we just want to exit that out. Now we want to navigate back to the Azure website. And we want to go to home. And you can go step by step and delete the virtual machines, the virtual network they've created. But if you just go to your resource group and you delete that, everything that we've created is inside of this resource group. So once you delete this, everything else will go. So click on the resource group that you stored your Windows virtual machine, your Linux virtual machine, and your virtual network. As we see here, here's our Linux, here's our Windows VM, and here's our network test virtual network. So you can delete the entire resource group. Copy this, paste it into here, Click delete and just wait for this to happen. Refresh. Notification will show up that it was deleted, but there's nothing showing up. Refresh again. You might want to refresh it a couple times. And now we see that everything on our main page is gone. We can double check, go to resource groups. There's nothing, this is kind of the default resource group that's always in there, but this doesn't charge you anything. It's just kind of default there. You go back, go to our virtual machines. We see that those are gone, and also the virtual network, and that's gone as well. So always try to clean up your resources and everything that you're using. That way, you're not getting charged any extra kind of money or anything for the stuff that you're using. So this concludes our tutorial on performing network activities and network traffic analysis using Microsoft Azure and Wireshark. And thank you for watching.